それでは本日最後のプログラム、パネルディスカッションを始めてまいります。エコテクノロジー4つ目の視座であるサステナビリティ、破壊と唐人からの脱却を切り口に、先ほどご講演いただいたアンダーソン博士、レディ博士、ルビアン博士、そして今年度の本田賞受賞者であるヘルムート・クレメンス博士を加えて進めてまいります。クレメンス博士は軽量構造用チタンアルミ金属管化合物の開発に貢献され、その業績により来週17日に第35回本田賞が授与されます。従来の常識である加工性が悪く室温で脆いという性質にチャレンジし、加工の際には柔らかく、使用される際には硬いという適応性を持つ TNM 合金と呼ばれる新たなチタンアルミ合金の開発に成功。増え続ける移動への需要に対して低排出ガス、低燃費エンジンでの活用により大幅な燃費低減が期待できるクレメンス博士の業績がエコテクノロジーの実践として高く評価されました。パネルディスカッションの進行モデレーターは本田財団業務執行理事、政策研究大学院大学教授須波敦様にお願いいたします。それでは須波様、よろしくお願いします。
すみません。それではご紹介に預かりました政策研究大学院大学の須波でございます。世界中からいろんな分野の、頭脳が結集されたわけでございますから、これを一つの方向性にまとめてやれというのは到底無理な話でございますし、今日もずっと先ほど来からいろいろな最先端の研究を踏まえた将来のビジョンについて講演がずっとされてたわけですけれども、一つの結論はですね、これからはおそらく今までのような線形型のリニアな発展ではなくて、どこかで非線形型なダイナミックな発展形態に変わっていくんだろうというようなことがであろうと思います。そういった意味ではこうしたそれぞれの異なった分野の頭脳が結集しているわけですから、このディスカッションもある意味で非線形型にですね、何が飛び出すかわからないような、そんなダイナミックなパネルになったらいいのかなというふうに非常に私も楽しみにしておりますので、よろしくお願いしたいと思います。時間が限られておりますけれども、実は今回のですねこのシンポジウムにいらっしゃる予定でしたハーケン博士の方からまずメッセージが届いておりますので、まずそちらをですねご紹介をさせていただきたいと思います。ちょっと私ので英語なんですけども読み上げますので、多分通訳の方が日本語にしていただけると思います。On the occasion of the 35th Honda Prize Commemorative Symposium, I am sending all of you my very best greetings. I had planned with great enthusiasm to participate at your important event, but sudden illness prevents me from coming. Nevertheless, I wish to quote the main conclusion of my intended talk on sustainability and synergetics. The formation of public opinion as governor of politics is essential. We know from many examples of synergetic systems the effect of small but active groups as initiators of new developments can be decisive and can lead to the cooperation of all nations, big and small, in politics aiming at sustainability of life on Earth. This underlines the importance of the activities of the Honda Foundation. I wish your foundation further great success. Hermann Haken, Professor of Theoretical Physics, Stuttgart University. それではディスカッションの方に移りたいと思いますが、このハーケン先生のメッセージも後でちょっとディスカッションの中で取り上げていきたいと思いますが、まず最初にですねこういうふうに進めたいと思います。 いろいろな方々のプレゼンテーションをそれぞれの先生方も聞いておりますので、まずそうしたことを踏まえて、さらにメッセージあるいはいろんな考えが出てきたと思うんですが、それを一人ずつご紹介いただいて、でその後、お互いに我々の方で少しディスカッションを進めていかせていただきたい。で、途中、後半ですけれども、皆様方からの、Q&A ということで、質問を受けながらさらに、ディスカッションを進めていければというふうに考えておりますので、ぜひ質問等あるいはコメントでも結構ですから、いろいろと今のうちに準備していただければと思います。Okay, so we'll start our discussion. So why don't we ask you first as to for initiate initial reactions.
Okay.
Dr.
Is this
Clemens.
working?
I think so. Do you?
I have to press.
Yes.
Okay.
Yeah, that's
Now it's working. So thank you for staying here after the lectures. So my comment is because I have taken this program, and the message of the president is that sustainability, which explores the direction scientists or engineers should take to face global environmental issues. I think this is a point because you don't know me that well, because I have given no lecture. So I'm in the field to develop materials which are used for new types of engines, for aircraft engines, which has reduced emissions of CO2 and also NOx, and reduced fuel consumption. And I think this is something which is really sustainable, because the problem is in our world we use too many of our resources, and also we endanger our resources by producing emissions like CO2. Maybe I start this discussion to give, because I did some notes during these presentations, and all of these presentations have been very good, very well to the point, and maybe if I'm allowed to start something, sure, I will do some comments, because Mr. Reddy, in his presentation, he spoke about freedom from slavery, freedom of religion, and also freedom of discrimination. This is points which are formulated long time ago. However, if you see how the world works, it's a big difference. So I see, when you see freedom of slavery, you give a comment how it's in India in our days, that so many people are endangered or are doing slavery works. Or freedom of religion, in my opinion, because if you look what's going on in the Near East now with this Islamic war and so on, I think in Europe especially we had really a good time when we had this so-called Enlightenment, when we separated politics from religion. I think this was very important for the progress of Europe, because we had a lot of wars in Europe concerning religions, but these wars ceased. So in the last 200 years we had no war on religion, maybe in Ireland, where they had problems, but however separation is good when you separate politics from religion. Freedom of discrimination is also an important point. We spoke about women, the role of women in our society, and in fact women have not reached the point they should really had so in their recognition in our society. Women still earn lesser money doing the same work, have not the chance to have this good education that the male people have, and so on. Maybe one point to your presentation with CO2 and water. I think CO2 and water, they are really related, and this comes back to my research, because if you have too much CO2 in the environment, you have a change of the climate, and this is what you see everywhere now, especially now in Europe. We have in the last 10 years a lot of change of the climate, and so we have lost a lot of money by damage. So things which never happened before occurs in Europe, so heavy rains, flooding, and so on. And one of this is related to the increase of CO2, and this is where my invention, or where I helped a little bit, because people know that more than 3.5% of the change of climate is related to air traffic, more or less. So just to give you a number, more than 600 million tons of CO2 is released in the environment per year, and one ordinary car 4 tons per year. But when you multiply the number of cars, you get enormous high numbers of CO2 emissions. And okay, maybe one point from my side, because you told us this diffusion of water molecules are very important for the human body. So in my case, because I'm a material scientist, I do not like diffusion at all, because diffusion at high temperature leads to very serious problems with materials. Very simple said, if you have a turbine blade and it's rotating, you have a force on it, and during high temperature, with the help of diffusion of the elements, the blades become longer, and this is things you are not allowed. I think this is my statement, maybe for the first round.
Okay, thank you.
Yeah.
Now I'd like to invite Dr. Levien. You're welcome to use Japanese if you want to.
ありがとうございます。でも、英語で大丈夫です。Yes. So, if we have to talk about sustainability, I'd like to talk about the stability of the mind. I think what makes humankind a little bit special compared to other animals on Earth is that we have developed a writing system. Started in the caves long ago, and the first humans, as we are, started to have drawings to communicate and to transmit some information from generation to generation. Then the real writing system came, and then we had books. So books were, a tremendous invention to transmit knowledge over generations. Nowadays, we have IT. So we have Facebook, Google, Microsoft, we have clouds, so we can store a lot of information. But my point is that we can transmit only what we are aware of. We can transmit only what we are conscious of. There are many things which we use to communicate among us, which we don't know how to translate. So when you exchange an email by internet, it's very easy, and you don't know exactly how the people will react to what you write. And I think all of us have probably some experience of mails that we regretted to send, for instance. And that's easy to explain. How people communicate is mainly out of language. We use, for instance, facial expression. There is eye contact, which is very important, and autistic people, for instance, are not able to get eye contact. So this kind of transmission of knowledge has to be preserved. So we should not forget, if we increase the number of robots, for instance, that we should not, we should be able to program something which is closer to how the human mind works. I have seen experiments done in, I think at MIT, where they had robots imitating human behavior. For instance, if you look smiley, and the robot will be kind to you. If you speak with nasty words, the robots will react in a nasty way. And it was very funny to see, of course, the robots have no emotion, but because of this kind of behavior, the people were responding as if they were talking to real human beings. So we have to be extremely careful that we should preserve our way of communicating until at least we have understood very well how the mind works, which is not for tomorrow.
Thank you. Okay, so Dr. Reddy, you want to?
This is a very interesting topic. I have so many different random ideas that I would like to share with you, but let me just stick to two. They're not related to each other. The first one is I was asking, what makes us not so humane? Why is the society not humane today? I believe maybe that's not a fair question, because I think we are a lot more humane today than 500 years ago, 1,000 years ago, except we don't know what all the things they did at that time. So when I look at the specifics, for example, we now have terrorism, and people are going around killing others, and I thought maybe it's just a religious thing. Now, even among the Muslims, the Shiites and the Sunnis are blowing up each other. And the same thing happened at 9/11. Same thing is happening with ISIS and ISIL. And I don't agree that Europe has not been, in the last 10, 20 years, has been free of wars and things like that. And take Bosnia-Herzegovina. It's kind of a complete disaster. I could not believe a civilized society would behave like that in this day and age. It's part of Europe, right? And you can go back to the use of, Holocaust and even the First World War, the use of chemical weapons. And people seem to behave in ways that a thinking, reasonable person would not behave, right? But there seems to be something about the way our brain is built. That's why I want to go back to Dr. Libuhan. We are aggressive human beings. There seems to be some aggression in all of us. Under certain appropriate conditions, we forget everything else we have learned and we become aggressive. And the question is there some way we can zap those water molecules to get rid of the aggression? So that's one kind of a thought, right? The other one is more positive and uplifting. It turns out, if you look back what happened 500 years ago, 1,000 years ago, 2,000 years ago in Japan, not much exists. It is very difficult to find anything even 100 years ago, because people have not been keeping most of it, and whatever is there in archives, most of us cannot have access to. Some documents are there, and then ultimately they'll stay in those basements, and they'll ultimately rot in a few hundred years more, and they'll be lost. Finally, we have a technology, we have the opportunity to capture our culture, our heritage, and our knowledge, and everything we do every day. That is, in the old days, people used to think of books and music and movies as completely different media, different things. Not anymore, they're all bits. And you can also capture them and store them forever. Not only the famous musicians, not only the famous movies. I can make a movie and store it in YouTube, and it'll be there. I'm hoping for 1,000 years. So that if you take a newspaper is, after it's published, two days afterwards, is worthless. And they're not keeping it. But they're all born digital. They can be captured and stored forever. One of the great things about information storage technology is, I paid $2 million in 1972 to buy 40 megabytes of memory. Today, I can buy 4 terabytes of memory, which is 1 million times more, for $100. So memory costs are becoming cheaper. To give you a number to remember, it's doubling every year. That means in 10 years, you get 1,000-fold improvement in storage, magnetic storage. In 20 years, you get 1 million times improvement. And that's going to continue for at least 10 more years, 20 more years. So the cost of memory is getting cheaper. So you can afford to store everything. And we should be doing that. That is, we should be capturing all the books, and all the music, and all the newspapers, and all the movies, and make it available free for the whole society forever. It doesn't have to be free today, but Caruso's songs I should be able to listen to for free today. But if it's making money, let them keep it as copyright. If it's not making money, then let it become public domain. So there are ways in which we can do this. So I don't want to take up much more time, but the important thing is there are so many things we can do to make society more humane. We should do that.
Thank you. Now, I'd like to ask Dr. Henderson.
Okay. I will tack on to one of the points made by Professor Lian on communication and the complicated nature of communication. There is somehow a rather common confusion of information and knowledge in the discussion about communication. We are all teachers, and we know that you cannot assume that if you have given absolutely correct information over the email to a number of students, that will actually be transmitted in the true sense. Teaching and learning is a very complicated process, and one has to be skillful as a communicator in much more sophisticated ways than any information technology has mastered. The teaching and learning is kind of transformation of information into knowledge. Knowledge to me is models and theories and sometimes even superstitions, but basically it's models. It's models and theories that are the soul of teaching and learning. And therefore, I don't have such a great trust in the information revolution or the communication revolution. It contains aspects like persuasion. You have to persuade, and John Maynard Keynes actually wrote a number of essays on persuasion where he showed that the trick in getting people to understand his theory had nothing to do with printing the books in very abstract ways. He said that you have to persuade, you have to convince people that you must give up your old ideas and you must learn these new theories, these new models. And that's a very time-consuming and hard work. So, and it depends on very intensive personal communication where movements of hands, contact with the eyes, iterating the same information over and over again and getting people to be friendly with what you are saying is a kind of trick of the trade. So beware of seeing the information and communication revolution as the solution of the problem of getting learning as a basic aspect of our future, and even more creativity and innovation as important aspects of development.
Thank you. I think, Dr. Reddy, are you ready to say something? Okay. Okay.
A short comment on our Dr. Anderson. I agree with what he just said, except I don't want to read into his comment that you should not be reading books or attending classes, because your teacher will communicate. Whether we like it or not, the information transfer process is imprecise, and there are experiments that were done where somebody said something, it was copied, many times, and then ultimately that's called hearsay in legal terms. A hearsay is not admitted because it's something when you transliterate after many people, it's not the same thing anymore, and therefore we have this problem. But nevertheless, we educate people in society, we communicate, somehow the imperfect knowledge is communicated. Sometimes maybe some innovation happens, maybe some other things happen, but we have to be aware of what the problem that is in impreciseness of communication. That doesn't mean we shouldn't write books or we shouldn't do it.
I'm a great friend of books, but
Yes.
my feeling is that it's only after teaching verbally, tutoring, I have managed to get the students to actually read the bloody books that they should have read at the start. It's an interaction between reading, tutoring, and having lectures and seminars and so on. And there is no substitute in the form of looking at a screen and becoming skillful. And especially if you would take a field like music. There has not been any successful first-rate musician who hasn't had intensive tutoring as a part of going from information to knowledge and from knowledge to skills. And the same is true of the lab physicist or the lab-oriented chemist or the doctor in a hospital. They have to be in this very important process where information from books and from screens and so on are a very small part of the total learning experience. That's what I would like to claim.
It's very nice to hear from the economists nowadays about the importance of reading books, so rather than modeling. But Dr. Louis, yes.
I agree on what you said, and then even go further away, that now you have so much information available. The brain cannot handle it. You have to model it. So we take only what we want. So the problem is that, for instance, I have seen that the brain needs to have many inputs to keep memories and to understand. So in the all good times, as we say, teachers were using blackboard. They would write things, equations or anything, and they will talk. Students had to write quickly because it will disappear. This was a way to get imprints in their own brain. Today you have a PDF. And this is awful because you feel that you can see many things. But maybe to prepare an exam, it's enough. I'm not even sure. But just a few months or years later, what do you keep? Nothing. So I think that the problem with information technology is that we are invaded by so much information that we don't know. So for instance, I give you an example. I'm sure some of you live in a house maybe, and you have a stair in your house. So if I ask you, for instance, to look at now, to the stair, you can see the stair very well because you see it every day. But if I ask you how many steps you have in your stair, usually you cannot respond, even if you have used this stair for 20 years. Because the brain has recorded some information which is useful, but the number of steps is not so much important information. So we are filtering information. So even if we have hundreds, thousands, millions of books, we will retain only what we want. And this is why we need to have people communicating. So then we can share common knowledge. And we have to be very careful about that.
Let me explore that a little bit more. Last week, I was in Scotland, and on the way back from Scotland, I was on the airplane. I was watching movies, usually that I do on a long flight. And there's a movie called Transcendent. It's about, Hollywood movie talking about the singularity problem, 2045. And you see the huge expansion of the big data that transforms the world, everything else that we know it. And there's a big discussions in Europe, for instance, about how the big data changes the way we produce new ideas, new knowledge, science 2.0, right? Because we do networking and you communicate. How, in your field, view this impact of big data that would change or transform, or what is the vision, or what do you think the influence would be? And okay, why don't you start from?
So I have positive and not so positive views about it. Big data, especially to understand the brain, is crucial. And maybe, in Europe, they have now what is called a Human Brain Project. It's a very, very rich program. And the idea is to put as much information as possible from many, many brains to understand the brain. So it's great. We have to do it. It's only way for us to understand is to have a lot of information. But what I usually say to my colleagues is that the information will not create the model. So you have very smart computers with many, many data. You need to have a program corresponding to your model. So if there is information which is not modeled, you will not see it. It's like a dark matter, if you like. We don't see it, we don't feel it, so we don't know it is there. And it's a lot of energy, in fact, we have in the universe. So I think it's the same. The problem with big data is that the problem is to retrieve the information, and we need models. Unfortunately, so far, computers, to my knowledge at least, cannot really, of course you can use some learning processes, algorithms which are able to see some information and classify information like vector machines and so on. But it's not the same as creating a model such, like we have in physics, for instance, coming out of the human brain. We are not ready for that.
Okay, Dr. Arms.
Well, there have been some tries of using neural network theory for, so to say, have an endogenous production of a theory or a model. Unfortunately, when you look into these, it turns out that they are critically dependent upon certain assumptions at the bottom. There must be some triggering mechanisms that somebody has come up with, and in order to get it going. So the model is there anyhow, although it looks very implicit. So that's one part of it. However, we have a school in financial economics that claims that we have already the consequences of enormous information flows in the stock market. The stock market is said to be a super brain because it aggregates all the wishes, demands, projections, and so on of all the investors into a price. Unfortunately, it's not very stable. So even if it works, we have the stability problem. And my problem with these mass data, for instance, the mass data in the traffic system, if that's transmitted to people who are very reactive on each other and on this data flow, they can actually generate catastrophes because they might be moving in massive conformity and just cause the problems that this massive set of data was assumed to solve. If we were completely independent of each other, not being interdependent individuals in a social system, then it might work. But we are, fortunately or unfortunately, social creatures who imitate and react on each other, and that can very often cause very severe instabilities in a rapid process.
Okay, Dr. Clemens?
I'd like to go a step back with the memory, because I liked your statement in your presentation that we should take care especially of old people, because there's a lot of information stored. The problem is, so for example, I have also a problem with my father-in-law. He's now 79 and he starts to lose his memory. It's some type of Alzheimer's disease. How do you think the chances, because there's a lot of memory stored in his brain. I think it's already there. Do you think in maybe 10, 15 years would be possible to read out such information from a brain?
Oh, that's a tough question. I think it might be possible to retrieve some information in some time. 10 and 20 years, I think, is too short. We were not ready to do that. The problem is that it's like when you have recorded information on a tape, for instance. You need a device to read the tape. If you lost the device, or if you have no device, what do you do? So today, in the brain, the only way we know to retrieve information is to talk, right? We don't have anything to pick up we don't even know what memory is exactly about. So if you want to retrieve information, we have to communicate, so that you have to regenerate something. But as I said, for instance, look at a stair in a house. You think you have a memory of the stair, but if you have a question, you cannot respond. So that means that you didn't memorize the stair properly. So I think that we have to be very careful about what we call memories. If there is an accident and you have 10 people next to the scene of the accident, and you ask them what they've seen, usually you have 10 different versions, right? If everybody had in the brain a camera, well, only one person will be enough, right? So we have to average out 10 different responses to get a clear response. So I think that what is memory exactly is not so clear. It has been proven now that some of what we call memories are in fact reconstruction. Very often children, they claim they remember some things they've done when they were 3, 4 years or 5 of age. We know that the memory is not very clear at that time, but they heard their parents telling them what they did at that age. At some point, this became, I remember what I did. But in fact, no, this was told to them. So I think we have first to understand really how memory works, what it is, before we can retrieve it artificially.
As you know, there is a worldwide effort now on dementia problem, and I think the Europeans and U.S. and Japan are collaborating to find the. There's so many economic loss and social problem associated with this, right? So
yes, but I think so far the idea is that if you lose memory, it's for yourself, that you cannot live in everyday lives. If you forget, for instance, that you have how to drive a car, or if you are where you are, then you cannot live. So I think the question, the urgent question, is to help those people not to lose memory. It's not to extract information stored in the brain to transmit to other people. This is your question, and I'm sure at some point we'll be able to do that, to suck up the information and transmit it. But we don't know the rules. We don't know how it works. So, but dementia is a very important problem, especially in Japan because you are lucky to have long lives, and it is the same in France. People have a long life in many advanced countries now. But if you have a long life and you cannot profit of it because you have lost memory or you have strong cognitive impairments, what's the point to have a long life? So we should really focus on trying to maintain the brain level. Brain will decline with age, but that's okay. As long as we can think properly.
So, Dr. Reddy, what's your reaction to the world with big data? I mean, you're working on a lot of cultural heritage or diversity problems, but they really comes from this idea that we control this big data and manage it, right? So
basically, I agree with many of the comments, but with the complementary additional thing. It turns out there's no question we have a data glut problem. Because of that, we are not even able to process all the stuff that we are supposed to, and a lot of things just stay there. That problem has always been there. It's just that we were not even exposed to it before because all those books were in the library. We never got to read them. Now they're all in a PDF. I have it on my Kindle, but it still can't be read. Having said that, I want you to caution, don't throw away the baby with the bathwater, as they say. It turns out there are a lot of things we used to have to remember, the skills that Dr. Anderson talked about, where we go from information to knowledge to routine skill, is no longer necessary. You don't have to remember your multiplication tables. You don't have to remember your phone numbers. They're already on your contact list. You don't have to remember a lot of things you used to have to remember. More importantly, there are a lot of things that you might know, but you forget. And sometimes you may not even know, but you want to find out. All it takes is a Google search. It's not a day goes by where I don't search for some piece of information I used to know, or I know I ought to know. 10 times a day, I find something that I should remember. I don't try to remember anymore. I'm not trying to, and that's okay. You don't have to remember multiplication tables anymore. You don't have to remember the phone numbers anymore because they're there. So in that sense, we need to kind of complement the fact having this big data and somebody else can search and give you some potential uses of information, is very important. For example, yesterday I was coming on the flight Japan Airlines 9. In the past, I couldn't, for any money amount of money, I couldn't find out. All I have to do is type JL9 into the search box. It tells me exactly where the plane is, when it's going to land, and all that information. It comes out of a data glut. Every plane, every information is there. I don't need to know it. But nevertheless, if there is a tool I have, and I can use it effectively, then big data is good. There is data glut, but I don't have to deal with it. Somebody else is dealing with it.
Okay. Yes, Dr. Anderson.
I think at this point we agree that it's good to have a toolbox. And if that toolbox is very easily accessible, and I see the information systems as parts of a toolbox, then it works much better now than it did long ago. I would like to return to the issue that was mentioned on the growth of people who are annoyed at development, who might like to fight in Iraq or Syria, or who might join an extremist movement in France or in Sweden or in Norway or in Denmark or in any other democratically very well-functioning context. And we've done some studies of this, and it turns out that the growth of extreme right movements in these countries is driven primarily by the loss of traditional jobs and the impossibility for these losers to find an employer who would like to hire them to do the new jobs. So with the transformation of the economies in Europe, we're bound to have this kind of growth of extremist movements. And some of them are actually then immigrants who have come from Syria and Egypt and Iraq and so on, and they are doubly confused about the future. So they might even accept a job with ISIS as a very attractive, although extremist, alternative to being unemployed. So I think one of the sustainability problems in this change process is to have a machinery and institutions that will generate new jobs for the people who are losing it when the old activities are abandoned in society.
That's a very important point. My professor, actually, when I was doing my PhD at Columbia, did a study on innovation across the different sectors and which sector is more innovative than other sectors. And as it turned out, the education is a sector that is less innovative. We haven't changed the way we teach people for years. We are very much in that sort of a rare realm where education becomes very important to make this kind of transition to be more sustainable. So would you care to comment on the education? Because tomorrow, Honda Foundation will be hosting the young engineers, scientists to get together for next generation engineers and scientists. Think about, their beauty. Yes, Dr. Ray.
So, this is a very important question. Basically, if you think of education of last century, basically what the teachers used to do is teach us all the things that are known facts. These days, all those facts are already available on the web. The question now is, what is the role of education? How, and the important, I'll give you a simple example. Going back to Dr. Behan, there's all this data, all the things. If I did not know that I could find some information, I would never know it. So it is not the case, I don't have to know the calculus, but I need to know basic principles of calculus so that I can apply more advanced ones when I need to do it by just-in-time learning. And the issue is how to restructure the education so that you no longer have to simply give facts that are already available. And what you need to do is give them the reasoning abilities to do problem solving, apply knowledge to solve problems you have. The question is, how do you do that? I was giving the example of a flight information. I have that problem. I need to know what's going to happen. If I knew that I could type it and get the information, that is the problem solving process. So we need to begin to give every child, every person, a series of skill sets to survive in the 21st century that is not learning all the facts, because the facts are there.
Yes.
If I may say something, we have two things to learn. We have to learn how to learn, so the processes. But we have also to learn how to memorize. So, at least in France, when I was a student, a child, there was some conflict about people who are good at math. And so they, for instance, with mathematics, you learn how to think. You are not, except calculation. You don't have things that you learn just by heart. You have to think to make some new ideas alive. While if you go to people specialized in history or geography, and they have to learn by heart many things. But we need both, because if we don't memorize, and I'm studying a little bit Japanese, and for the kanjis, for instance, to write the kanjis is very important to memorize. If you just look at the kanjis on the computer, you never memorize them, and then you never learn how what they mean. A bit that's my problem, but I think we need everything. This is how the brain works. We need, as I said, many inputs. So we need to consolidate our memory. So even to learn by heart things which you can retrieve with Google doesn't hurt, because it is training your memory. And you know, for people who get Alzheimer's disease, for instance, we try to maintain their memory. Even you learn stupid things, it's good enough. So I think we have to balance how to learn things which you can even find. But the day you lose your smartphone, and if you have put all your phone numbers there and you have nothing, and then you are dead.
That's always the case. I want to reinforce what Dr. Behan said. There are 3 phrases he used: learning to learn, learning to think, reason, and solve problems. The third one is memorization is equivalent to what Dr. Anderson called skills. Supposing you needed to do something, and there's no substitute for learning kanji characters unless you practice them. And those, all the 3 skills are needed, except what used to be thought of needed skills in the 20th century is no longer the skills you need in the 21st century. For example, I come from India, where the sounds are the same, but the letters are different in 20 different languages. There are 20 different scripts. Europe is safe that way. There's only use one script. And the problem is, I don't want to learn all the 20 scripts. And so what I do, I have the same letters transliterated into my language. I know how to speak with intonation and everything. When I see it in my language, I can figure out what to say. So it turns out, depending on the technology, depending on where you are in time, we need to be able to say, what should you memorize and what should you not have to memorize? And for example, this kanji character learning thing may go away in the following sense. All I need is a smartphone, and I take an image of it, it reads it and tells me what it is. And then I don't have to actually learn the letters. And it can be done today. The same is true with respect to translation. I'm in a meeting, another country, I don't know how to speak. All I need is my smartphone to transmit it, translate it, and then play it back to me. And this technology was demonstrated in the last 3-4 years. We can do speech-to-speech translation now, and that doesn't mean we don't need regular translators, but there will come a point in time where no matter what language you grew up with, you don't have to learn all the other languages because you can listen.
Okay, Dr. Anderson.
I once studied a famous mathematician, Polya, who was from Stanford, and he kind of summarized his learning as a teacher. He wrote a book called How to Solve It. And what he claimed I found very useful as a complement to what you have said. He said, first, the most tricky thing to get people to understand is how to not only elegantly but also productively generate problems. Formulate problem. How can you formulate a problem that nobody has formulated before in a way that it's amenable to analysis? And once you've done that, and if you were a student, you've learned to see this as the basic part of creativity, then you come to the question, how can you solve it? How can you solve this formerly unknown problem? Because there is obviously nothing in the toolbox to be used directly. So he said, you can use analogies. there are analogies maybe from very strange parts of the knowledge field. You might be a physicist who wants to do something that no physicist has done. So maybe you should go into the deep cellars of mathematics or to chemistry or so to dig up some thing that seems to be similar and sufficiently similar. And I found this a very nice way of opening up some students' eyes. When I ask them, they come and say, what should I write my dissertation on? And they want me to formulate a problem. And I said, well, the only important thing is that you do something completely different from what I've been doing. And then they look very confused, but some of them come back after a couple of months and have actually by themselves formulated a new problem. And then we can start discussing what analog structures are available to solve this problem.
Okay. Yes.
In fact, we know today that the brain works a lot by analogy. So what is learning basically is to have experience about what should be done and what should not be done. If I say, for instance, a cat, you can think about a cat because you have seen one. Otherwise, there's no way, right? So children, especially when they learn by analogy. So try to compare different situations and try to mimic. So sometimes it's not appropriate, they make a mistake, then they will not do it again. So, and it goes very well. For instance, some people have shown also that the way Einstein's vision came was just by analogy. I mean, if you look at the two articles he wrote for the relativity, one in 1905, it's not E is mc square. It's E divided by c square is some kind of mass. Even Einstein himself didn't catch what he found. And in his paper on the general theory 2 years later, then he reversed the equation to E is mc square, and then he said, well, this mass must be the mass. So you see, I could say that he was thinking, from what I could read now, just by comparing different fields or different ideas, and trying to propagate knowledge from one area or one field to another one. And I think it is really how the human brain works. So we don't have a digital brain. We have an analog brain.
Okay. Now I'd sort of like to invite the questions from the floor. And so if you, at this moment, if you, もしここでですね、一度、はい、質問を受けたいと思います。じゃあ、そこにいらっしゃいますね。じゃあ前の方。
認知科学学会、Cognitive Science Society で発表をしております。それでこういう話をかつて聞いております。アンダーソン先生に関係するんですけど、アンダーソン先生は先ほど複雑系は、最短のアルゴリズムであるという重要な発言をされたように思います。で、私はカオスの研究者から聞いた話なんですけど、脳の中にも、パイをこねるようなパイこね変換と数学で呼ばれるカオスの出るような変換活動があると、複雑系が出ると、パイを、遠くへやったり近くへやったりパイを練るわけです。パイこね変換っていうんですけど、そういう過程が脳の中であって複雑系があって、脳はそれによって広域的な知識をスキャニングしてんだと。そのカオスを生かして広域的な知識、広いブローダーナレッジを、操作してスキャンしてるんだと。スキャンしているのではないかということを、研究者が聞いたんです。で、先生が先ほどアンダーソン先生が言われた複雑系は最短のアルゴリズムであるということと見事に一致しているように思うんですけど、先生のご見解と今の私の例の適合性はいかがでしょうか。
Well, there is one problem for me in answering this question, and that's I know too little about the brain. So I think that part you will have to deal with. The basic idea between, or the basic relation between complexity and chaos is a very sophisticated discussion that's now going on among mathematicians, because it turns out that complex systems are at the heart of Gödel's theorem, which means that there are certain problems where you cannot actually prove that a statement is correct, but you can know intuitively that it is correct anyhow. And that's especially when in situations where, let's say, a number series is so complex that it can only be described as chaotic. And yet you can somehow grasp that, or the brain can grasp that there is some structure to it, even if you can't get a computer, for instance, to solve the problem, even if there is a well-behaved algorithm around. And already Turing struggled with this problem and made a version of Gödel's impossibility theorems adapted to a general computer. So this is a very, very complicated issue as far as I'm concerned. But maybe the brain...
Complete your response with the brain side. Well, it is obvious that the brain is complex, but we should take the word to the definition. We know today that complexity is really how the brain works. In fact, in a sense, if you go to the bottom, like molecules, if you sum up all the molecules, you cannot create the level which is above the molecular level. So there is some synergy, something new which is coming out of each element at the molecular level. Then when you go to the cellular level, again, if you put all the neurons together and everything, that's not enough. Something else is coming in synergy out of the collections of the neurons. And then you have regions, and again. So each level is not the sum of the elements at a level below. So this is complexity. And also we know that the brain doesn't work linearly. It is highly non-linear. And some even people think that it's similar to quantum mechanics, if you like. When I talk, for instance, about the fluctuation in the brain, this is what we see now. There are fluctuations. The system is somewhat chaotic. Some fractals have been used, for instance, to describe the electric waves produced by the brain. So, but we are not aware because what we see, what we feel as in a conscious state is only a very small part of all the machinery which is permanently occurring in our brain. And as you know very well, when we are completely asleep and we start to dream, the fourth level of the sleep, we are totally unconscious. We are dreaming, but then this is the time the brain is the most active. So a lot of information is processed at the time, and this information processing will shape up the brain. This is how we make our memory. This is how we learn. So the brain is really a model of complexity in a real sense.
はい、はい、じゃあ。
今日の主題でありますその人間性あふれる文明を作るということに関しまして、現状から未来を議論しているだけでは視点が少し狭すぎるのではないかと、歴史から学んで、歴史は繰り返すという言葉もございますが、将来のサステイナブルな文明を考えるときに、例えば日本の文化ですと、平安時代は貴族的な文化、江戸時代になりますと大変庶民的ないろんな歌舞伎とか芸術絵画でも 非常に庶民的な文化は発展しているけれども、非常にもったいないという精神で安定した文化があったと思うんですが、で過去から歴史から学んで将来を議論するという視点に立った場合に、ヨーロッパではそういうふうに何か将来のサステナブルな社会を考えるときに参考になるような事例があるかどうか、ヨーロッパ、インド、各国の知恵あるパネリストにお伺いしたいと思いますが、いかがでしょうか。
Who wants to go first? Yes.
This is a very interesting question, but I think it's not specific to Japan. I think it's true that there are periods where things are stable. Like if we take, for instance, the Middle Age period in Japan and in France, it was completely different, but it was somewhat stable. So you had the organization with the shogun and everything, but at some point, some chaos is starting, and then this is how you change from one system to another one, from the Middle Age to the modern time. In France, it was exactly the same. In the Middle Age, the system was very, very stable with the king and the people, and everybody has his own territory, and that was very stable. At some point, for some reason, people started to think differently, and the system had to change. So I'm not sure the history is repeating itself. It's just that you have for some time, something stable as a society, and then we switch to another system. And this has been in Asia, in Europe. Of course, United States is much more recent history, but I think it's not reproducing the same. It's just evolution, but you have steps where everything looks stable. That's what I feel.
Okay. Anybody? Yes, Dr. Ennis.
Well, I think that there are certain things to be learned from history, and that's especially for the countries who have not yet become industrial societies. We know that Japan got a remarkable rate of growth because they were, like Sweden, latecomers into industrialization. So we could benefit from all the errors and mistakes that had been done or experienced in Britain. So it was very common in Sweden and Japan to make trips among innovators to Britain, or a little later to Germany, to see how have they organized production, how have they been working. And today it's even more useful to look at the history of the countries that have had a very rapid expansion like we have had earlier. Now we are slow grower, but earlier we were very fast growers because we were imitators and learners. And today, in Africa, for instance, in some of the countries who have started their industrialization process, they benefit from benchmarking and going to and see what other people have done before them, and to use the useful organizational principles and the useful technologies and so on, and thus they grow much faster than we could do. China is a good example of a very systematic learning from history, but one shouldn't go too far back to learn. I don't think it's meaningful to go back to the medieval time, for instance, in Europe, and try to learn anything except negative things. You can see how it works when power is monopolized by small groups and hierarchies become too stable and not inclusive and so on. Otherwise, there is not much to be learned by going very far back. But going, let's say, 100 years back can be a very useful type of historical studies for the developing countries.
はい、ありがとうございました。他にありますか。じゃあちょっと他の方にも。はい。
本日はどうもありがとうございました。私もですねトランセンデンスの映画見て、シンギュラリティをここ3、4ヶ月ずっと考えているものなんですけれども、チェスで、カスパロフとディープブルーですか、あれが1996年7年で、チェスが勝って、で現在そのチェスと人間の戦いはチームでグループチームを組んでそのチーム同士の戦いやってる。で日本ではですね去年と今年プロの棋士5人と5つのソフトで、戦って、で去年も今年も多分私の記憶では1勝しかできなかったんですね。人間が負けました。でチェスと将棋の違いはやっぱりチェスよりも将棋の方が駒が多いし取ったものをもう一回使えるっていうことで複雑なんですけれども、やっとそのコンピューターが将棋の世界でも追いついたと言われてます。それで面白いのはですね、その去年チェスコンピューターに負けた棋士がそのコンピューターのソフトで勉強してで一緒にやってるうちに彼はスランプにいたんですけれども、今年すごく成績が良くなったんですね。で今年はそのコンピューターのソフトを棋士に貸してですね、それを一生懸命こう勉強して作戦練って、それでうまくやった人は勝ってた一人で、それから考えてですね、こう人間とコンピューターの関係、結局、プロの棋士もですねコンピューターのソフトから思わぬ手を教えられる、今まで自分が勉強してきたことと違う新しい発想が得られるということでコンピューターから学べるわけですね。で先ほどビッグデータという話がありましたけど、ビッグデータというのは結局人間にとって見えない世界がどんどん増えていくことになりますから、お医者さんが例えばコンピューターで出てきた結果で分かんないけれどもこれで診断するみたいなことになってくるし、人間とコンピューターとの関係がもう劇的に変わるんじゃないかなと思うんですけれども、この辺についてちょっとどなたかご意見いただければと思います。
それでしたらドクター・レディにまず聞きますかね。
What you say is very true. It turns out there was a phrase coined by Licklider, J.C.R. Licklider, in 1962. He is the grandfather of Internet. He is the one that actually started the work, started the research on that area, and he also coined the term intergalactic internet network or something like that. But one of the phrases he coined was a phrase called man-machine symbiosis. So essentially, anytime you can have a human being and a machine who have worked with each other, understand who is good at what, will always win over a computer or a person, because they bring to bear the best of both worlds in some sense. In particular, for most of the games of the kind that you're talking about, chess and Go and so on, it is now possible, given the terabytes or petabytes of data available, it's now possible to put inside every chess game that has ever been played and every move for every condition. That's not the same as all possible moves, which is more than the number of atoms in the universe, but every game that has ever been played can be put. If you have that, then all that you have to do is do a table lookup or search in the Google search sense to just look up that particular move and say, did it lead to a win or not, and then do it. Most of the interesting new results will come in the interstices. If you come up with a new position that nobody has ever seen before, what do? At that point is where the computer's power comes in. It can actually explore millions of possible moves and find out what is the best solution. Once it finds the best solution, it becomes part of the folklore. Every chess player will learn that particular thing, saying, if I know this, I can make this move. And as we know, grandmaster chess players know 50,000 different patterns, whereas most of the rest of us maybe know 1,000 patterns. And that's the difference. They have so much more knowledge. And when they find a new position, new winning strategy, that becomes their winning thing. So basically coming back to the discussion on cognitive science and cognitive memory, the evidence now is, if you look at what happened with Kasparov and the Deep Blue, the evidence is that it won mostly by brute force. Little bit of knowledge and a lot of brute force search. And the evidence now, at least in looking at the brain research, is a lot of the stuff in the brain is brute force. Namely, it can recognize there are different parts of the brain, 10,000 faces. Each one has a separate computer that detects your mother and father and your brother and everybody. It's completely differently localized. And at the same time, that doesn't mean there should not be a complexity model that tells us this concept is understandable, it's simple, this complex is context. That's where mathematics comes in. That doesn't mean the brain uses that particular structure, but it's better to understand it. Similarly, for example, not everything can be formed into a mathematical principle that Livahan was talking about. A lot of the things that we know currently are all completely statistical models. It is not precisely formulatable as model. I think you mentioned quantum mechanics. Quantum mechanics is mainly probabilistic mechanics. And so the issue here is brain may be operating on a quantum mechanical basis, and that may be an interesting possibility.
Sure.
So when I was a student and learning IT, so in the end of the 70s, I remember very well my teacher gave us a definition of a computer. It's something stupid with a very, very good memory. And in fact, I think for our brain, that's exactly the opposite. We don't have such a strong memory, but we can think. And the problem is, or the advantage of the brain is that it is highly parallel. We have millions and millions of cells which can do processing in parallel. And so far, even with the best computers we have, we are very far from that. And now there's evidence also that the brain is using the Bayesian theory. so weighting different outcomes and comparing with what has been learned in a completely non-conscious way to decide what is the best behavior. In fact, the brain we should consider as a machine to protect ourselves, to avoid that we die. And so it's a learning machine, always learning. Even for all people, we are always learning, and we are trying to decide what is the best for us. Sometimes we make mistakes, of course, but this is our brain is here to protect us, to preserve our life.
今の子は生まれた時から IT とか PC とかが周りにある状態ですが、先生方のお年からするとそうではなかったと思います。幼少期の体験の中で、例えば自然に触れ合うとか、そういうことはやはり重要だと言ってくださると嬉しいのですが、例えばそういうコンピューターとかと触れ合うのは何歳ぐらいからの方がいいとか、そういうようなお考えはありますでしょうか。
That doesn't mean they shouldn't go out into the nature. As Dr. Anderson was saying, you spend only 7% of your life, maybe 10% working. So 10% of the time, let them work with IT. 90%, you do whatever else you want to do.
Yeah, I think we have to be careful to teach our children that life is not only in computers, and there is real life, and what we call social network. I hate this word, social network with Facebook. There is nothing social. So we have to be extremely careful. But on the other hand, I talked about genes and the brain. If you give to a child a smartphone, in a few minutes, he knows how to operate. He could not even read the manual or nothing. So genes are not responsible for us to use smartphones. So I think that if such devices are used in a good way, it can benefit the development of the children. I mean, for them, we have to realize that it will be like a pencil for us today. I mean, 1,000 years ago, this would be a very strange instrument, right? So, I mean, if we don't make mystery about the devices, and well, it's part of the daily life, but as you say, there is nature, communication. This should not be forgotten. Unfortunately, there are teenagers and they playing with game, for instance, with internet. For them, this is society, and that's very dangerous, of course. So we have to be careful.
Dr. Anderson?
I would just like to ask a question to the brain specialist, and that's, I've been wondering if Haken's idea of fast and slow processes might not be useful in understanding the workings of the brain, because if you have a nonlinear system like the brain is, it would be chaotic most of the time, and we know that we are not chaotic most of the time. It happens now and then, but on the whole, people are quite predictable. And I discussed this once with a famous differential equations guy who wanted to model the brain, and he actually said that in order to model the brain with his mathematical tools, he had to separate it into two parts, one which was slow and the other that was fast. And I wonder, is this the case, that the brain is actually subdividable into two interactive processes where one is kind of stabilizing the other part?
Well, it's not completely that way. I mean, there are different scales, as I said, different scales in space. So for molecules to cells to network, it's the same with time. So there are different time scales. So at molecular level, at cellular level. So yes, and we can see that, for instance, in the electric waves produced by the brain, there are different frequencies. But it's not only two. So some processes are slow, some are fast, but they are interacting all the time. And even chaos is present. It doesn't mean that the brain is globally chaotic. It's like the weather. And we know that there is a lot of non-linearity in the weather, but we can predict it somewhat. And so depends on the time scale you talk about. Yeah.
Okay, Dr. Ray.
So there's a Nobel Prize that was won by Kahneman on slow thinking and fast thinking, and it's another way of kind of talking about cognitive science, what we know. There are things you memorize. If you memorize them, you immediately recognize them. Therefore, they become fast thinking. Things that you don't know that you have to reason about, and that's kind of a slow thinking. There's nothing magical about them. It's all known in psychology and cognitive psychology for many years.
Thank you. I think we're almost about running out of time, so I think we should close now. But before we go, there is one sort of important question that you raised, in which I have some questions that I have been collecting from the previous from office. How do you make us human more humane in a way? Is the innovation, eco-technology a solution? You talked about separation of state and religion, or state and faith, and that's sort of the beginning of the rise of modern science. And now yet we are facing so many complex problems, including religion and other sort of things. And this is a very and so I anybody want to just do? Okay, why don't we go take a turn and make a short, brief statement before we close?
Yeah.
So, Dr. Ray.
Right. The only solution I know is education about ethics. And Dr. Anderson mentioned about it. Maybe he should talk more about it, mainly because until we train the next generation about what is right and what is wrong, and put them in the shoes of the people that are being tortured, put them in the shoes of the people that are being, and then build up their empathy, then we are not going to have a humane society, because most people have not been taught. They think they just can do anything and get away.
Okay, Dr. Love.
Yeah, I think maybe I will respond by a question. If we say more human, what is human first? And I think it's a big question. Researchers now, some of my colleagues, are trying to understand what makes us different from animals, for instance. Is there a difference, or is just a continuity? And I know, especially for the brain, people are focusing now on, is there a way to understand what makes humans different from non-humans? And I think this is an important question, because if we want to be more humans, we should understand first what humans are. And that's not so easy, in fact. That's a very, very difficult question.
Dr. Clemens?
Yes, I think maybe it's quite simple. The answer to get a true human society, I think if you give everybody a chance for the future, I think you will solve all the problems. I think this is the problem, that you have areas on this world where people have no future. So especially young people. So to give them, and I agree fully with you, what we really need is a full education, a good education for young people, and then we need a transfer also of the money, because in Europe or here in Japan, everybody is living on a high standard. If you give the other one a little bit of our high standard, I think we can solve a lot of problems.
Dr. Anderson?
Well, I think that the key word is tolerance, because you know the old saying in France about brotherhood. I think that's a devastating idea, because brotherhood means you care for your brothers and you don't care for the ones who are not your brothers or sisters. Tolerance means that you can accept anyone, and you will look upon anyone as a human being and accept the deviations. And I think that's the first thing. The other thing is, as you said, to provide a place in society for everyone. Everyone should be needed somehow. And you can be needed by being employed, or you can be needed in some other way, but everyone should have a feeling that he is needed. Otherwise, he will migrate to any society, criminal or whatever, where he will be needed. The third thing is something I don't know, but I've heard a lecture on it. And that was a lecture by a biologist, or I think he was a zoologist, who said that what makes humans unique compared to the other primates is that this is the only part of the primate system that has an inbred capacity to educate. That each one starting already with the baby, starts educating the baby and goes on teaching them how to solve simple problems all the time by imitation and so on. So tolerance, a place in society, and proper use of our inbred capacity to educate each other, and especially the younger generations. I think these are three parts of a human society.
Thank you very much. それではもう時間になりましたので、この辺でパネルディスカッションを終わりたいと思います。今一度パネリストの先生方に拍手をお願いしたいと思います。